I'd like to welcome Lydia Fraaije and Jan Brunkhorst to the Regenerative Insights Circle, and we're excited to hear what you have to say. The floor is yours.
Thank you very much. And I think it's best if one introduces himself a little bit more.
For sure. As already said, my name is Jan Brunkhorst. I'm originally like an environmental scientist working together with Lydia here in the Symbiotic Systems that we founded now 1.5 years ago, I think.
Mm-hmm.
But also I'm working in the fields of agri-photovoltaics or agrivoltaics, and in general we are looking into how to build together with nature and how to become how to quantify our ecosystem services in order to get to a more sustainable building development.
So I'm Lydia Fraaije. I'm a biomimicry and biophilic architect, and I'm not sure if everyone knew something about biomimicry. So because I do all of my work within the perspective of biomimicry, we're going to have a short introduction in this. And then I'm also going to show you how this works in practice. So Jan and I created a model to quantify ecosystem services, especially for spatial development, based on the principles of biomimicry. Here we go. So our logo was because nature and humans, actually we are nature, so it blends over into the same thing. So fingerprint and tree trunk. This is what I told you. So first a little bit of theory, biomimicry perspective, and then what limits and boundaries actually are within an ecosystem. Oh, yeah, and before I forgot, thank you very much for your invitation, because I really love this community with its multidisciplinary community. And the first time I joined, that was one of the things that really spoke to me. I think it's a very good basis to create some change in the world. So we're going to talk about the limits and boundaries of ecosystems, and then in practice, showing a little bit about the current status of this house. It's called Vita Pura. It's Latin for pure life, and it's a biomimicry showcase house, and it's the first in the world, as far as I know. So, and then I have a bigger assignment for a green tech business park. A building there, but it will be only some images. So just to get an impression on the possibilities, what you can do with this tool. So first, biomimicry. We're going to look through the eyes of nature. As you can see, there are a lot of different eyes, and we as people are a visual species. So we see a lot, and then we think we know a lot. But if you look at through the perspective of nature and through these other eyes, for example, an eagle can see a mouse on a distance of 2 kilometers, and there's a really cool hermit lobster that can see all the colors of the spectrum of light, so from ultraviolet to infrared. So I'm not able to imagine what the world of this little lobster looks like. I think it would be mesmerizing. So, and it's not only the eyes that actually tell us something about the world, give us a perspective, but these species also have other talents, like dogs can hear a lot better than us. So there's not only one perspective on the world, there are a lot of perspectives on the world. For biomimicry is learning from the 3.8 billion years of research and development of nature. And nature has designed actually everything much better than we did. We don't give a lot of credit to nature, because I think everything we do, we learn from nature in one way or another. And when nature designs something, well, not consciousness, but when something is designed in nature, then it does it with no waste, efficient energy and material use, by self-assembly, and by chemistry and water. So, and I think these topics, they are very important in current society to find more sustainable solutions. One of the oldest examples of biomimicry is this. This is a thistle, and there was an engineer walking through the meadows with his dog, and there were some thistles in his coat of the dog. And when he came home, he tried to pull them out, but they were very stuck. And he thought, well, this is kind of an adhesive way. It sticks together. How does this work? So he took a really close look to the thistle. And as you can see, there are like little hooks here, and they cling into the fur of the dog. And when you pull them out, you can put them back in, and the thistle sticks in again, and you have to pull it out again. So we thought this could be a sustainable way of being adhesive with not only one use. For example, glue is usually one use, and then you pull the material, it's broken. But with this, it stays intact. So this was the basis of the development of Velcro. And you can see the little hooks here with the thumb. Where is my mouse? There it is. So you can see the little hooks. So this is the thistle. And this is actually these are little loops. This is the fur of the dog. This is biomimicry by model. So you have by model, system, and process. That's how you can replicate or emulate nature, learn from nature. But this is plastic. So this is not as sustainable as we can be. And within nature, there are always feedback loops to evolve. So maybe for the next step, we can have a bioplastic, so then it's even better. If you look at biomimicry, this is a schedule from the Biomimicry Resource Handbook. It's written by Dana Baumeister. And she is a biologist that has translated all the elements of nature into more easy translatable sentences or words that you can use in your daily life or in your business to bring nature into your daily life or business. So emulate, that's this part here, is the translation of the thistle. So that's the technical part. Learning from nature, so tapping into the enormous database of nature. But you have to do it very consciously, because it's learning and it's not copying or stealing. It's like really learning with respect for nature. Ethos is also one of the essential elements of biomimicry. And this is why we should be more sustainable, or why we should use biomimicry. And reconnect is actually finding the connection with nature again. And this is knowing that you are nature. And this is in a circle, because if you know you are nature, you probably have more respect for nature. And also if you see what the enormous database of nature is, you also get more respect of nature. So this all works together. I think the next one is a short movie. I hope it works. And this says a little bit about ethos and biomimicry.
Some call me nature. Others call me Mother Nature. I've been here for over 4.5 billion years, 22,500 times longer than you. I don't really need people, but people need me. Yes, your future depends on me. When I thrive, you thrive. When I falter, you falter. Or worse. But I've been here for eons. I have fed species greater than you, and I have starved species greater than you. My oceans, my soil, my flowing streams, my forests. They all can take you or leave you. How you choose to live each day, whether you regard or disregard me, doesn't really matter to me. One way or the other. Your actions will determine your fate, not mine. I am nature. I will go on. I am prepared to evolve. Are you?
So I don't know if you all know this film. It's, I think, kind of known already, but as people, we think we need to change the world, and we are responsible for the earth to be more sustainable, and we place ourselves above nature. Since the Industrial Revolution, it was also kind of easy to do so, because we could take from nature, and we could throw our waste back and nature would solve this for us. And also nature was kind of scary because it could kill us. But in the meantime, we forgot we are nature. And so this is the ego. And with the ego, we need to see that we are completely dependent of nature, because we are nature. And we are dependent because without plants, we don't have oxygen. Without bees, we don't have food. And without ecosystem services, we have nothing at all, actually. So I think we should be more responsible and place ourselves within nature, or even see that nature is our mentor. I kind of have an explanation, sorry that this is in Dutch, on why we act the way we act. This is a time frame of 24 hours, it's a clock, a day. And this is actually development of the earth. And if you see underneath here, this is when the earth, around 12 o'clock, the earth's atmosphere is containing oxygen. Then if you go up here, so that's halfway the day. If we up here, this is 10 o'clock, we have the first land animals. And then 10 to 11, we have the dinosaurs. And 20 before 12, the dinosaurs are extinct. And then if you should look at this, we are this little stripe here. This is when people come to Earth. So we only are here 20 seconds before midnight. So we are a very, very young species. And we also act like a very young species. We have still tried to find our balance within the ecosystem. And I think we are an intelligent species. So we have a possibility, and we are very flexible. As you could have seen with COVID, I think we also have a talent to fit in within the ecosystem. Let me see, are there any questions about this already, or should I go to the next one? Well, okay, then I'll go on, or I don't know what this kind of, yeah, okay. So we're talking about limits and boundaries. So what can we learn from nature about limits and boundaries? So this is one of the images I'd like to show, that now this is actually separate for us. But we can use nature as a measure, and that's why we developed the ecosystem services. Again, within biomimicry, this is one of the lenses there is, and this is the life's principles, and these are the conditions on how ecosystems operate. So let me see. So life's operating conditions, so life creates conditions conducive to life. So in this gray area, all the conditions, the operating conditions are mentioned. So life runs on sunlight, water, and gravity. The earth has a dynamic non-equilibrium, so it's always in movement, and there's never a stable balance. It's always dynamic. And so that's also kind of weird, because we are making math with a really exact number, so 0, 0, but in nature, 0 is never 0. It's always an in-between. Then there are limits and boundaries, where I'm going to talk about, and cyclic processes. So all of these are very interesting, but I'm going to fix to limits and boundaries. Oh, let me see. Oh, what is this? So what are boundaries in nature? So boundaries are environmental abiotic conditions. For example, the height and closeness of the area compared to the sea, the longitude and latitude of a place, and information in your DNA, for example, the genetic ability for growth. So what we actually should realize, and that is not really represented in our society, is that there is no endless growth. So economics is based on growth and on endless growth, but in nature this doesn't make sense. There are also limits, and limits in nature are the amount of nutrients, sorry for the typo, the amount of water, the intensity and exposure to daylight or sunlight, the temperature, time, and other things. So if you look at nature, this is actually what boundaries look like. So this is completely different than our boundaries or our borders that we created. And it's of course not for a bird. It's really ridiculous to not be able to fly from Germany to Holland. So this is a little bit the basis and the perspective of why we developed this tool. And now I'm going to tell you a little bit about the house. So this is the piece of land we bought. This is our fire truck, and this is also a camper. So we lived in it for a while, for a weekend. I mean, we camped here for a weekend to really get to know the place. So before we bought the land, we stayed on the land to get a really feeling with whatever there was there. So how the sun works, what about the wind, there's a street next to it, just really find out how the place feels. So this is an image of it. So this is, we bought a caravan, that's where I'm living in now, and you can see it here. So this is where I'm in now, and this is before we start building it. These are our neighbors. So what we did with Jan is, when you build something as an architect, or you do some spatial development, usually you scrape off the topsoil, and that's like the most fertile soil, and that's where everything, the entire ecosystem grows out of. And if you scrape it away and you place a building onto it, without thinking about what it could deliver back to the ecosystem, it's actually almost zero. But if you think about it differently, and you think whatever I'm going to place back can contribute and fit in within the limits and boundaries of an ecosystem, you have a completely different mindset, a different perspective. So what we did is find a reference ecosystem where there hasn't been done a lot, and this is nearby. It has the same type of soil. It has been, okay, not this part of the grass, but for example here, we made an inventarization of the how many ecosystem services there are delivered. So how many nitrogen is fixed, how many CO2 is stored, what the infiltration is of the water in the soil, climate regulation, water provision, biodiversity, all these types we measured. And this is like an ancient ecosystem. There is no ancient ecosystem in the Netherlands, so this is the closest that we found. And so we quantified all these systems. And when building something new, looking at it from a different perspective, you can actually, all of these things you can provide within your new development. If it's a building or something else, just think about it. So this is a render of our house. So this is not built yet. And our house, it will provide the same ecosystem services as this reference ecosystem. And because in the in the Netherlands, a lot of these ecosystem services are really degraded because environments are destroyed, we thought it would be good to enhance like every ecosystem service, not only like fit in, but actually contribute like every other organism in the world. So this is what the outcome is from the model. So you can see all different kind of ecosystem services at the bottom. And for example, denitrification. So that is, I think it's about nitrogen and how it's captured. There was not a lot. Water provisioning, there was also not a lot. So this was the reference ecosystem. But still, this is from a 0 to 1. And it still kind of has a lot of ecosystem services if you compare it to other ecosystems. That's the findings we have now because of some experience. So we did the same for our piece of land, and some other things came out. And this is how you can see, for example, if you compare the design before it was built and 7 years after, because ecosystem service, of course, if you put some mitigational measures in, it will grow. So, and I think an ecosystem has about 7 years to have a cycle. Sorry for that, there was a big motor coming by. So we try to measure it every year, and then the cycle will be, I think, complete around 7 years. We still have to figure this out how this works because we just started. So we're not on 7 years of experience yet. And then try to compare if it actually works. So as you can see, one of the things here at this is again a render, is that we have a green facade, and in the soil there is a lot of sandy soil. So if heather is one of the things that comes there naturally. What we did is also, this is for insects, this is for bats, and there is some for swallows, I think they are called. No, not really. Well, for other birds here. So we already had some, next to having a lot of greenery, we also have some housing for animals here. This is our halophyte filter. This is actually cleaning our wastewater and infiltrating the water again into the soil. So one of the ecosystem services here is purifying water and bringing it back into the soil. So countering drought. And of course, a green facade has a lot of ecosystem services, and we are developing it right now. I have some pictures of that. Oh, this is the house in construction. So this was in November. We built it with prefab straw building. And underneath you can see someone sawing off a beam. So this is recycled wood. And this recycled wood was the basis of the house. So the measurements of this wood defined eventually the shape of the house. As you can see, the neighbors are building too. So we have neighbors here and neighbors here. And this is my husband with the yellow sweater on. And you can see these are the elements that are still lying there. And we actually have very little waste building this because everything is made in the factory and it's placed upon each other, and that's it. So this is one of the floors that is coming in. And these are the window frames. I'll just skip to the end a bit. Well, this is the next phase, so that's where the roof came on. Then the roof was on and everything was watertight. The stairs came in, And this is how upstairs looks like. So this is the living room. And above is a meditation room where the guys are standing. That's an office, like yoga space. Oh. Sorry. This is upstairs, the second floor. The view, the cat likes it too. This is the right one is in the living room. This is the house packed with foil because this is water resistant, vapor transporting, and UV safe, UV protecting of UV. And this is where we are putting the facade on, and the facade is charcoal wood. And this is a natural process, a Japanese technique, and you don't have to have maintenance in 50 years. So that's really special for wood. One of the things we did to actually measure ecosystem services is you have these Eddy Green, Eddy Max monitoring systems for inside and outside, and these are air quality monitors. So kind of keeping track on how much fine dust there is. These are these two, how much toxins, CO2, humidity, and temperature. So it's kind of interesting to know how this works in our new house, to monitor it. This is a test of the green facade. What we did is having some sedum. So these are like plants that really can live under harsh conditions. These are going to be on top. Then we have some plants underneath. These are plants you can eat, for example. And we're just testing out what it is. This is when it's just planted. So now it's already a bit more grown. This is the halophyte filter now. You can see the facade here. It's finished. And here in the top, there will be the green wall, or the roofs will be green too. And then we've got an assignment to figure out how this also can apply to business parks. So I made a design for this building. So this is a machine building company that has a very social idea about how they want to work. And this is also a sustainability campus where people can come. You have startups and scale-ups here. There's room, and it's a biomimicry academy also. And we developed this park. So where you see the empty areas, the lighter grass, there will be other companies too. But one of the biggest things is that we have a park. So you have a parking space and then you have to walk through the park to go to the business park. So every time you experience nature when you go there. And of course, there needs to be a good transport. So there's a road there too, but that's not for visitors. And you see a lot of solar panels and an atrium here, a green spot on the roof. And that's actually the presentation for now. And I think I would like to discuss it a little bit with you, how you think maybe this could apply within your business, or with how you think I think this in the Netherlands, we are ready to going to integrate this into projects. And I'm just was wondering how this is for the rest of the world, because this is like a multidisciplinary worldwide network. I think it would be interesting to know a little bit about that. And maybe Jan has something to contribute to.
Yeah, like first of all, thanks for the presentation. But in general, like I would just like to add that the main theory that we have behind our model and how we basically came up with like the biophilic and biomimicry integrated design was just by looking at, okay, like how can we make the ecosystem services, first of all, measurable and then also quantifiable, in that sense that we looked at like a quite natural ecosystem, as Lydia explained, which had like a similar habitat type. So we went to like the nearby area, which was pretty much exactly the same habitat type when it came to the plants, the animals living there, and in general, like the overall ecosystem itself. Took the measurements there where we really figured out, okay, what were our indicators, and also which indicators are actually giving us the best results or coming closely to define our ecosystem services. And with like this close to natural state of this ecosystem, you have a reference on which you can build up on, because we measured our ecosystem before, or the building site, we measured like what ecosystems are there at the moment, compared that to the reference ecosystem. And as you can imagine, because it was already kind of the developed land, it was below, but not as much as we already like thought of in the beginning. And now we implemented like all these measures, which we developed based on the lack of ecosystem services, and really looked into the biomimicry handbook, I would say, to define measures to really pinpoint and push these ecosystem services which we were lacking on the building side, in order to come up with like a really sustainable building design, which makes it possible for us to integrate the building into the environment, the local ecosystem. And therefore, when we continue the measurements over the years, we can see the impact of all these individual measures in the way that we see an increase of ecosystem services. And at the end, the main goal is to increase ecosystem services overall, and not just the one that were decreased, and see like something similar to like the reference ecosystem, where we had like very little human intervention in between. But yeah, that's pretty much everything I wanted to add to that. Yeah,
thanks. That's a good summary of it all. Thanks. Are you moderating, Andrew?
Yeah, I'm happy to do, Lydia. That's okay. As you like, but I see Jean-Louis has his hand up. So go for it, Jean-Louis, and raise your virtual hand if you have a comment, or wave your hand or whatever. Please go ahead.
Yeah, this is great. Thank you. It's a beautiful model. And I have a specific question. There's a company here in Seattle, which I'll just mention because it might be interesting for you to know about them, called Green Canopy Node. Mm-hmm. And they've been getting quite a bit of traction in the US actually with their building design. It's different because it's more an all electric, so I don't think they use biomimicry principles, but they are getting very good traction, building pretty large developments in the US. So just mention that, and they're actually connected to them here, so if you have an interest. My question is around the ecosystem services, which of course gets very technical, and we can do that at the level of an individual home. Of course, for it to be kind of recognized in its full value, ideally it would scale up, right, to the level of a town, of a jurisdiction, of a county, of a region, of a city, right, of a nation, where you can really see then how it all accrues, right, to the total regeneration that we can create, or conversely, you know, the degeneration that we create. So I wonder, is your system connected in the Netherlands with some kind of either municipal system, some kind of legislation, some kind of framework that would allow you to scale up, right, the benefit that you can show house by house in a way where you could aggregate over time, and then it becomes really visible and can be also rewarded, right, financially and otherwise, through taxation systems and subsidies and all sorts of things at the level of a jurisdiction?
Well, that's actually the aim we have, but it's looking at the world in a different perspective, and we are kind of getting foot onto the ground. Like we're getting some. We actually have an assignment for Rijkswaterstaat, that's like the infrastructure company of the government, where we did an assignment for. And this actually helps to also have the government think about the possibilities of this model. So we have some individuals, we have some companies that are interested, but I completely agree that we should have this on a national level or a municipality level or whatever. But we're working on this. But first we have to have some, now we're actually in the phase that we have some projects and we want to prove that this works and show people what the benefits are. And I think we're a little bit with the early adapter phase still. So
yeah. Maybe if I can add a little bit to that, the main thing of what we try right now is to show that it's actually possible to quantify ecosystem services in like a really specific framework and therefore make it measurable and comparable. And this only works right now on the scale of one ecosystem or one habitat where you are basically interfering with your building. But of course, if you want to scale up, that's possible, but then we need way more data about like the ecosystems that are basically like building the environment where you want to develop your project.
So, and actually our house is a little bit too less of a scale. It's better to have a little bit like for Rijkswaterstaat, the infrastructure company, is that scale is like pretty good. Then you have like a really good insight of an ecosystem. Like only for our plot we have 1,000 square meters of land. That's on the small side. So but actually we're doing this for the green facade too, making a model together with a biologist from the University of Utrecht, trying to quantify the ecosystem services only for the facade. But it would be better to, like for the business park, then that's the scale that things should be worked out. That's the best scale for now.
Good, thank you. Leopold.
Yeah, I have 3 questions. How is the water harvesting working? And the second question is, what heating system are you using? And my main question is, how is it the software for modeling is, what did you use, and is it for free use for everybody?
Well, the first with the water harvesting, it's actually purifying the water and containing the water. So harvesting is done with the roof and then gathering it within a system to eventually water our our garden, vegetable garden, and our facades. But the halophyte filter is actually for purifying wastewater. So that's like from the toilet and the shower, and that's purified by the bacteria that are in the roots of the filter, and they love to eat all this kind of waste. And then water that comes out is clean enough to infiltrate into the soil. So and that's eventually we will make a wadi, because that's also really contributing to biodiversity. So I hope that's enough of an answer to your question, your first question.
And you calculated that it is enough, which is coming from the roof?
Well, that depends on, of course, on how much water rain there falls. So, but it's at least it is a contribution. So I think in the Netherlands, I live in an agriculture area where a lot of farmers extract water from the soil. So every contribution of water that we have is an extra. So, and actually harvesting water, so maybe for drink water is illegal in the Netherlands.
Yeah.
So for the heating, we have a tichelkachel, you probably know. No?
No.
Well, I think it's It's like an oven that you have with there are a lot of them in Germany. It's with stones that heat up, and they give the heat of in during the day. So it's a biomass stove where we can put in wood from our garden, so like the small chipped wood, not like big trunks. It's not necessary to have like the big trunks. So actually it's the debris of what the leftovers from the garden, if you garden. You put it into the stove, and then within 1 or 2 hours, it has a really efficient burning process. So it has very little fine dust and CO2 outcome, and it's also monitored by a sensor. But because our house is insulated so well, we have the littlest stove possible, because we think we almost can heat up our house with a candle, because it's actually airtight but damp open. So there's not any air that goes out of the house, only the damp within the house. And we have some extra, because nature always has multiple ways of solving something. We also have another way of heating, and that is with infrared panels and an infrared column. The panel is for in the bathroom, because we are only there for 2 hours a day. So that can be heated up, and then we don't need intensive heating there all of the time. And as you could see upstairs, we have like the column, and that's we think all of the heat that is at the bottom of the house will go up. So there will not be needed a lot of heat upstairs, but the column is there for extra heating. And because we are only with the 2 of us and the cat, it's a replaceable column. So everywhere we sit, you can put the column next to you, and it has like a kind of a big range on how the heat is dispersed. And then for the software, that's actually what Jan and I agreed on not to talk about too much, but we are still in, we have an American company that works with us on it. And I think we would love to share stuff, but not yet. So if you keep in contact, I can share it with you, but not yet. So.
Thank you.
You're welcome.
Sorry about that, I was on mute. Dave, go ahead.
Thanks, Lydia and Jan. I mean, it's so beautiful to see this stuff, and I think it's like so motivating to see the possibilities. I just think that, you know, you really help expand people's imaginations when you show this off. So thanks very much for that. I want to follow by, maybe it's on the software question, I don't know exactly, but I've got a Jones to try to figure out if there's some way to create a landscape data set, an open landscape data set that people would be able to use to plan projects that I think would look like what you're talking about. And I guess one of the things that would be interesting is to try to do it at a to try to let people define their own scale, so that they're able to define the landscape or define the watershed. And so I guess what I'm asking is, like, does that sound vaguely interesting? And if so, maybe I can talk to you about it more later. But
it sounds interesting. The model right now is you can also define your area. So, and you have to define separate areas with different qualities. So for each ecosystem service, you define the area with boundaries, actually, a little bit like that. That's how it works, doesn't it, Jan?
Yes, like I would just like to add that we have the luxury that specifically in the Netherlands, there is a lot of like data available from the government, where you see a lot about the habitat types, the land use at the moment, and how also it went back into history. So you have a little bit of historical data as well to see like how these ecosystems developed over the years. And that is very helpful, of course, for our work. And that would also be like the main point of where you start. You look at like what ecosystems are in the area where you want to develop something. And then you basically figure out, okay, like what is the normal ecosystem or like the reference ecosystem that you can find for these ecosystems that is kind of still in a natural state. And then you define of what you can do in order to get closer to a natural state while still building your artificial structure or whatever you want to build there, if it's a building and so on, you know. So you kind of need to orientate yourself on what is already there and given by nature, and then look, okay, how can I adapt to what is already there? And how can I influence it in a positive way rather than a negative way with my building?
Great. I would love to talk to you guys a little bit more about this at some point, if it's okay with you.
Yeah, I think for scaling up, what you suggest is a good idea, I think. So probably we're not there yet, but it's good. Yeah, you have to start sometime. So that would be.
Yeah, you guys would be, you've got a use case, I guess, of whether, and the idea that maybe whether or not the data, having the data readily available matters to you is kind of one of the indicators, right? If you have to create a whole bunch of it yourselves, is that, that's the question, I think.
Well, during COVID, Jan, like being an environmental technologist, and we had Rin from Finland, is she?
Estonia.
Estonia, sorry. And we had Lynn. She is a biologist. There were all the data we couldn't find, we tested ourselves. So we had like a chemistry kit defining, I think, the nitrogen or the pH of the soil. And
like
we had
a lot of the data that we kind of needed in order to get like our indicators, indicator measurement. We needed to figure something out because all the labs were closed in the Netherlands, so laboratory equipment was not always available, and therefore we had like a lot of like creative outcomes on how to get like kind of reliable data in the way that we can like make our assumptions based for the indicators to bring it to like a state and a comparable value that is like giving you enough information to say something about the ecosystem service that you want to try to measure. And of course, the more data that is already available, the better it is for you, but there's always the direct measurement on the spot necessary in order to get like precise and get your indicators right.
So for the CO2 measurement, we burned up biomass, but that was actually in a pottery atelier instead of a lab. So it was, we were very creative with finding all these data. So, and thanks for the ecolo tree in Iowa, Andrew.
Yeah, I can put you in touch with them if you're interested. It's pretty interesting. I see Liana has a question, and if anyone else hasn't asked a question you want to, we're just at the end of our time, but so raise your hand. We've got time for a couple of questions if you like. Go ahead, Liana.
Yeah, I just wonder how long have you designing all these things and exploring and then making like the Olvis ecosystem?
You mean how much time it took to develop this?
Yeah.
Well, I was thinking about it for, I think, 5 years back. And usually these things, like all my other companies, grow like this too a little bit, and I have an idea. But at some point things come together. So I met Jan and Rin and Lynn, and then that was the moment to start developing. And I think it was in the beginning of COVID, so almost 2 years ago, that we actually started developing it. So and I think we've come a long way. So we have nice prospects.
No, for sure. I think like the actual measurements and figuring out what indicators we wanted to use for the model, that was like half a year pretty much. That was the project time there. And then the designing process started. So then Lydia really got into like the depths of the designing board and what biomimicry can offer. And then the results are slowly getting real, but I don't know, like what is the time frame right now on when you want to finish like the actual building?
Before Christmas, I want to live in it. But then again, it's a biomimicry showcase house, so it's actually a living lab type of thing. So I will probably continuously evolve while living there, evolve the design. So it will never be finished.
Good. Anyone else? I've got one little question, but I want to make sure that anyone else who had a question is able to ask it.
I'm not sure if Liano had the right answer to her question. Was that what you were asking?
Yes, thank you.
Okay.
And so my question is, do you intend to go in the direction of thinking about sort of the cost benefit side? Right, so if you're norming it to whatever's in the environment, but that's doing something other than what's being done everywhere else, right? So I'm just curious if one's thinking about the societal benefits and the financial costs and benefits, whether you're planning to come ultimately with a model that says, yeah, this is actually ahead of other, standard construction on this, and this. So it's essentially extending the measurement field, I guess, is what that's the way I think of it. Does that make sense?
Mm-hmm.
Yeah.
Well, with the biomimicry framework, we think it has to be good for all organisms on Earth. So there are some, if you look at ecosystem measurements, then usually you also have like recreational value or food production and that kind of stuff.
Yeah.
And I actually want to take it out of that sphere and really come with a different perspective. So if you want to use a model, you do it for nature. So, and then economic value is something that is not that important. So it's really a mind shift, actually trying to get without getting out of the system of the capitalist system and really create a mind shift. And this actually kind of works already. So I hope to get this through till the end and really not have anything to do with economic value.
Okay, that is a topic for another discussion. I would love to. That's great. Thank you. It's a perfect answer.
Oh, okay.
I just want to thank you very much for coming to explain your project and the way you're thinking. It's really a privilege to get a view that you've given us. So thank you so much. And for those of you who are interested in recording, it's going to be on the Slack, GRC Slack. And I'll provide one to you, Lydia and Jan, of course, if you want to use it for anything as well. Okay.
Thanks.
So,
yeah, thanks for having us. Thank you very much.
And thank you for the interesting questions and your also active reactions and stuff like that. That's really cool. So yeah, thanks a lot.
Good. Thank you, everyone. Come on back next week, probably a similar time, maybe not exactly this time, and we do Wednesday mornings CET as well, 10:30, in case anyone here would like to join us. Okay. Thank you.
Thank you.
Yeah. Bye.